Just a short video for fun from the shack here this evening to show how you can visualize the operation of an antenna tuner like this one here by using a vector network analyzer and setting it up with a couple of displays, each of which will show you the operation in a slightly different way. Well, normally when you use an antenna tuner like this, you're tuning up at a particular frequency. So we're going to do the same thing with the VNA. We'll set it up in zero span, in this case at 7.2 megahertz. Now the analyzer is set up with 3 displays, but each display is really just measuring S11, the reflection coefficient, but it's displaying it in 3 different formats. Down here in the lower right corner is the traditional logarithmic magnitude of the S11, but again we're in zero span, so we're going to have a flat line. The reflection coefficient is also expressed as the standing wave ratio, or SWR, which is the most common thing that hams will look at. So I displayed that here as well. And then thirdly, we're also displaying the reflection coefficient as the complex impedance looking into the coax. So this is what the transmitter would see on the Smith chart here. Now, the Smith chart is just quickly a way of displaying a complex number, in this case complex impedance, where we have essentially circles that represent constant resistance, and we've got arcs that represent constant reactance, both inductive and capacitive reactance. And the location of where you are on the chart tells you essentially the complex impedance. So right now, before we start adjusting the tuner, we've got our marker sitting right at our single point at 7.2 megahertz, and that's giving us a input impedance looking into the coax of 20 ohms plus J 38 ohms, so an inductive 38 ohms and a real part of 20 ohms, and that's what that point represents. Now if I reach up and grab the capacitor control on the tuner, I can see a couple of things. I can move the impedance that's seen on the Smith chart kind of on an arc as we adjust that capacitor. I can also see the return loss and SWR curves moving as well. If I grab the roller inductor of the tuner and start adjusting that, I can actually see myself moving along on the Smith chart as well as the other displays. Now our goal is to get a 1-to-1 SWR, which will be achieved when the input impedance is right here in the center of the chart, right at 50 ohms resistive. So all we need to do is essentially adjust our controls to kind of get us there. And you can see if I adjust my inductor down, my capacitor back here, and get ourselves really close, if we're really careful here, and zero in to something very, very close to just a 50 ohm resistive termination. And if we look here now, I'm at 49.7 ohms and about 0.4 ohms of inductive reactance. And if we tweak that a little bit more, I might be able to get even closer. Okay, and with ourselves very closely centered here, we take a look at our SWR plot, and we're sitting at 1.008 to 1, and our return loss is 47 dB. So we've achieved a really, really good match by simply tuning the capacitor and inductor on the tuner and visualize that a couple of different ways. Well, now that I've tuned up at my desired frequency of 7.2, I've changed the VNA to give me a span of 400 kilohertz. So now we'll sweep from 7 meg to 7.4 megahertz, which more than covers the 40 meter amateur radio band. Now of course on the Smith chart I can see the input impedance to my antenna system. Now what I mean by that is the antenna, the tuner, and the coax leading to the transmitter. And this is what that impedance looks like over frequency. And if I can drag that marker around and actually see what that impedance looks like at any frequency within that sweep, going back and forth. Okay. Of interest to most hams would probably be this plot right here, which is showing me my standing wave ratio, or SWR, versus frequency. And I've actually put a pair of markers here at the 2-to-1 SWR points. And this indicates that I've got something in the neighborhood of about 140 kilohertz of 2-to-1 SWR bandwidth. So covering not quite half of the 40 meter amateur radio band. And of course, of interest to most RF engineers would probably be just the log magnitude of the reflection coefficient, which is shown down here. But all of these are essentially the same measurement, just displayed a couple of different ways. And today's video was basically just for fun, but I do plan on doing some more tutorials on the use of a VNA for various applications in the future, as well as maybe even some tutorials on the Smith chart itself. You know, an old tool that RF engineers have used for many years, but maybe a bit of a lost art these days in terms of how you can actually use it manually. So maybe we'll cover that in some future videos as well. Anyway, if you like what you see, give me a thumbs up. If you haven't subscribed already, please do so. Comments are always welcome, and thanks again for watching. See you next time.